Sometimes you will be behind a HTTP proxy. This is likely when you're at places like work, school, university, private networks. If you look in the browser settings for the machine that you are forced to use when you're on that network, you can potentially tell whether or not you're using a proxy on that network. So you will see something in here, maybe here, HTTP proxy. And if you do, you need to note down the IP address and the port number. If you're on Windows and you look at Internet Explorer, that will show you if there are any system proxy settings. Again, note down the IP and the port number. You can also be using a transparent proxy, which means there will be no settings in here. You will just automatically go through the transparent proxy. And also you can be on auto detect proxy settings, where you'll be using some form of proxy auto config or PAC or PAC file, which look something like this. So you'll have to try and locate the PAC file, and then if you do, you might be able to find the proxy's IP address and port. Note down the IP address and ports of any proxy servers that are in here. This file is likely to be on the proxy server as a file you can download via a web link, or it could even be a local file. There are two main types of HTTP proxies that you are likely to encounter. Now, many HTTP proxies don't actually proxy HTTPS. They only proxy HTTP, and that is because HTTPS requires more administrative efforts. They have to make more changes, they have to add encryption certificates and other sorts of things. So instead of proxying, what they do is they forward the HTTPS traffic onto the final destination, as long as, of course, the final destination's domain or IP is allowed. And they do this using something called the HTTP connect command that essentially opens a private tunnel for the browser to use. Proxies that do this generally should be easier to bypass, as there is no content inspection of the HTTPS, and you can create a good tunnel with HTTP Connect, which I'll show you how to do. Now, so that's the first type. Second type does do full proxying of the HTTPS protocol, meaning that when it gets to here, it breaks the encryption. There is no end-to-end encryption between here and here with these second types of proxies. And because they have broke the encryption, they are able to filter here based on the contents of the traffic. So how do they do this breaking? Well, on a private network, this is normally done by placing a certificate on the browser. The browser then, wherever it connects to with a HTTPS connection, or sometimes all connections, it creates an SSL connection to the proxy here, and that's where it ends. That's where it is broken. The proxy then examines the traffic here, and if it's okay, it then forms a second SSL tunnel here, or SSL TLS connection to the final destination. And it does that on behalf of the client. Now, of course, it does require a certificate on here. If there is no certificate on here, there's no certificate installed in the browser, then you will get warnings saying that there's a certificate security error and that the certificate is invalid. But this is actually a very, very common technique in businesses that want to proxy HTTPS. You use their device, they put that cert on there, and they break the encryption at the proxy and are able to see all of the traffic. Still, it is potentially possible to get through this second type of proxy as well. So let's look at some ways of doing this. So the first tool to try to get through a HTTP proxy is Corkscrew. Corkscrew is a tool for tunneling SSH through HTTP proxies, as it says, and it supports a multitude of operating systems, including Mac OS X. You can even get it on Win32 with Cygwin, and also Linux, of course, and it is available in repositories. On Debian, for example, on Kali, sudo apt-get install and then corkscrew, and you will be able to get a fully working version from the repository. So what we're going to do now is we're going to open up a dynamic SOCKS port proxy on our local machine that sends traffic through the HTTP proxy and then on to the SSH server. To open the connection to the SSH server, we will first try to use the HTTP connect method, which allows a client to connect to a server through an HTTP proxy by sending a HTTP connect request to the proxy. And this is how corkscrew works, so that's what we're going to use. So let me explain this command here. So we're SSHing on port 22. Now this you would need to change. This is likely to going to be port 80 or port 443. This needs to be whatever your firewall happens to allow out. And then we're going to run additional commands, which we're going to do through the proxy command, and we're going to run corkscrew. We're going to run the program corkscrew, and the first thing is it's going to connect. That is the IP address of the proxy server. That's why we needed to know it. And then this here, 8118, is the port of the proxy server. And then we're going to open up a dynamic SOCKS proxy locally on 8080 that connects through to demo.stationx.net. Once we have done that, we can put in 127.0.0.1 port 8080 into a browser, and that browser will go via the HTTP proxy and then SSH onto demo.stationx.net. So let's give that a try, see if it works. So there we are, we're on the SSH server. So that has got us through the HTTP proxy. So I'm enabling my browser to go through that proxy. So 127.0.0.1, 8080, SOCKS proxy, remote VPN. And there we go. I'm coming from the Amazon data center in Dublin where the demo server is. So there you go, able to get through a HTTP proxy, not too painful. Remember, you need to change this to a port that the firewall allows. And of course, you need corkscrew and you need to know the IP address and port of the proxy. If the HTTP connect method is not available or corkscrew just isn't working for whatever reason, then you can try another tool. We have proxy tunnel here. I just scroll down. You can see it is available for Windows, OpenBSD, NetBSD, so it should work on Mac. It is available for Debian and Kali and is available in the repository under proxy tunnel, so you can just simply get it there with an apt-get install proxy tunnel. And this is the command you would use. If we look here, we see this is very similar structures to what we previously did, but we're just using proxy tunnel here instead. Now see, we've got port 22. Again, that needs to change to whatever port is allowed out of your firewall, port 80, port 443, etc. So here's the actual command, proxy tunnel -p. This is the IP address of the proxy server. Then 8118 is the port. And then again, we are creating a local dynamic SOCKS proxy and we're connecting to demo.stationx.net in order to create that SOCKS proxy. So let's give this a try. This one gives us a little bit more information here. It shows us that we're going through this HTTP proxy and we're going through to this SSH server here. And there we go. And there we are. We're coming from Ireland again, so we're successfully getting through that proxy. And you can see there, connected to the local SOCKS proxy on 8080. Now, not all proxies are going to play ball, I'm afraid. There are many things that they can use to try and stop you getting through. First one is authentication. So it may be that you need to authenticate to that server. And here you can see the command here. So I've added -P with proxy tunnel, and you enter your username :password, and you can pass your username and password to the proxy server. If you don't want to put your username and password in the actual command because it will show up in the process list, then you can use -F and just put the username and password in a file like so. And this is with proxy tunnel. And with corkscrew, you can do the same sort of thing. You can do it from a file. So there you go. You put the username and password in a file and it will send that to the proxy server. Some proxies may even want more information, like your browser's user agent and your referrer. Now you can still provide this using proxy tunnel. If you notice, this command is the same as what we've just been using, but the difference is here we've got this -H, and then here we're adding the agent in quotes. If you're not sure what your agent string is, then just do a search for user agent and paste something in there for your user agent. And it's got the host here with the -H, taking the variable here from here. And then we also have referrer. And again, we're taking the variable H here. And then -P, username and password, and then creating the local tunnel. Now, that's getting a little bit large, isn't it, now as a command? So there is an alternative. Because the command is long, what we can do is we can set up a default command to run per host. And we do that by editing the config file, which will be in the .ssh folder for the user that you want to run this command. So let's edit this file. And I've actually pre-populated it here, and this is what you're going to need. So host is the nickname for the server that you're going to connect to. User is the user you're going to connect as. Host name is the IP address or URL to your server, or domain name for your server. The port you're connecting to, this is what will be 80 or 443 for you. The dynamic port that is going to create the SOCKS 5 proxy that it's going to create locally that you're going to connect to. And then this is the proxy command. This is the same as I've just shown you. And you could put any of the previous proxy commands just in here. And you can see it goes on and on. So now, if I save that, if I do SSH demo, it's going to do the full proxy command, proxy tunnel, because I have that configuration in my config file, and it will create that local SOCKS proxy with just this command, because demo is the host. And there we go. We can see it's connecting through the HTTP server to the SSH server. And there we are. Go on here, refresh, and there we are. The tunnel through the HTTP server using SSH is working. And there are some other options, but I can't go through every one, but the good ones are HTTP tunnel. This is some software that you put both on a server and on a client, and you create connections between the two. So instead of using SSH, you're using this instead. This is available for Windows and Linux, and it is available in the Debian Tails repository. And then Windows-wise, you've got HTTP tunnel, which looks like this, which you can try out. There's Barber tunnel, you can try. There's Super Network tunnel, but that is a pay-for solution, which looks like this. And then if you're in a Windows environment and you need to do NTLM type authentication, this is a authentication proxy that might enable you to get through a HTTP proxy, which may help you out if you're needing to do NTLM authentication. So that's getting through HTTP proxies. In most cases, with one of these tools or techniques, there's a good chance you will be able to get through. But of course, always remember about consequences. If the consequences are high, all of these techniques could be discovered by a keen administrator.